Welcome to another coding problem, Subarray Divisibility from CSES problem set. And this is another prefix sum problem from Unit 1. Let's take a look at the problem. So once again, this is a crucial concept that I'd like to mention before we get going any further. If two numbers have the same mod, so two numbers have the same mod or the same remainder, same mod. So mod is another word for remainder. Their difference, so x1 minus x2, is going to be divisible by 0, or their mod is going to be 0. So let's take a look at the prefix sum and the concept again. So since we all know what a prefix sum is by this point, this should be fairly simple to you, but it's written a bit more advanced. So the sum from the ith element to the jth element is going to be the sum from 0 to j minus the sum from 0 to I minus 1. Kind of like complementary counting. Take a moment to pause the video here and understand the sigma notation here, as this is the formal way to write this. So this was our original array in our sample test case, 31274, and this is the new prefix sum array that I've constructed. So this should be very simple to you by now. All I'm doing is I'm just summing up these elements like the boxes I'm drawing up here, and then putting it down there. So 3 plus 1 is 4. 3 plus 1 plus 2 is 6. 3 plus 1 plus 2 plus 7 is 13. And as you all know, this takes O of n to construct. And now that I have my prefix sum array here, I'm going to take the modulo of it. Prefix array. Notice that the size of this is 5, so I'm going to take mod 5, and you'll see later. So mod 5 here is 3. Mod 5 is 4. Mod 5 is 1. Mod 5 is 3, and mod 5 is 2 once again, I believe. So this is my new array, my new prefix sum array, where all I've done is I've taken mod 5 for each element. And notice that the percentage sign is the mod sign for each element. So notice that when I calculate a subarray sum, what am I going to do? All I'm going to be doing is I'm going to be taking two prefix sums or two values from my prefix sum array, and then I'm just going to be subtracting them. But notice what I've said, and that's going to be the sum. So the difference between the two prefix sum arrays or the two prefix sum elements is going to be my subarray sum. Now, when I do that, remember this concept that I've talked about here. When I take away two numbers that have the same modulo, their difference is going to be equal to 0. So all I need to do here really is to find two numbers that have the same modulo. Ooh, and we can see that 3 and 3 here, they have the same modulo. So we know that if we subtract 3 and 3, the subarray sum is also going to be divisible by 0. Because look at what happens here. Let's say that I have 13 here, and I also have 3 here. If I do 13 minus 3, I'm gonna get 10, which is divisible by 5. So all I have to do is I have to choose 2. Choose 2, and this is the combination notation, or you can write it in C notation as well, which is the same thing. So from 0, and I represents the modulo here. So for each modulo, for each mod, what I'm going to do is I'm going to choose 2 from each mod and calculate how many number of ways can I do that. So our answer is going to be the sigma, or the sum, from I to 0 all the way till n minus 1. And I'm going to be calculating how many ways can I choose 2 out of 10 modulos, let's say. And once I sum them up, that's going to be our answer.